Let's use the moment generating function for a negative binomial random variable to derive its expected value. Here's the moment generating function of a negative binomial random variable, mx of t. It's pretty complicated. It's a fraction. It's p to the e to the t, all raised to the r power, over 1 minus q e to the t, all raised to the r power. Or again, it'll always q is 1 minus p. Both things individually are being raised to the r power. That means you could take this entire fraction, put parentheses around it, and raise it to the r power if you wanted to. You also could use a property of exponents to write the numerator as p to the r times e to the r times t if you wanted to. It's not a big deal. Let's differentiate this with respect to t. P, q, and r are all constants, and e is the number e. So if I'm going to differentiate it as is, I need the quotient rule. I will also need the chain rule. You also could write it as the numerator times the denominator to the negative r power and use the product rule instead. It's going to be kind of a mess. No way around it. Quotient rule. I remember it as low d high minus high d low over the square of what's below. That's how I teach it. Low, bottom. D high means derivative of the top minus high, the top. D low means the derivative of the bottom. Over the square of what's below, it means over the square of the bottom. Low d high, oh, the derivative of the top with respect to t, I need the chain rule for. Bring down that r, subtract 1 from the exponent, and then multiply times the derivative of the inside function. The derivative of p to the t is p to the t. That's low d high. There's the low. All this is the derivative of the top. Minus high d low, differentiate the bottom. Once again, use the chain rule. The derivative of the inside function is negative q e to the t. Wow. All over the square of what's below, 1 minus q e to the t to the r squared, which can be written as that thing to the 2r. So there's the derivative in all its glory. Should we simplify it? I don't think I want to, but I will plug in 0 and simplify that. That's going to be the expected value of x. Moment generating functions are great. This is less work than trying to use the definition of the mean to find the mean. I'm not saying it's easy, but it's doable. All the e to the zeros become 1s. Right? E to the 0 is 1. So this one becomes a 1 minus q to the r, which is p to the r. 1 minus q to the r is p to the r. Times r times this thing, e to the 0 is 1, is a p to the r minus 1. Times another p times 1. Continuing over here, plug in t is 0, e to the 0 is 1, you get p to the r times 1 minus q to the r minus 1 is p to the r minus 1 times negative q times 1. All over 1 minus q, which is p, to the 2r. This is supposed to simplify to r over p. This term simplifies by adding exponents to r times p to the 2r. This all simplifies to plus rqp to the 2r minus 1. Two negative signs make a plus there. you can factor out a common factor of R and P to the 2R minus 1, leaving you with, from this term, a P, and from this term, a Q. How about that? That cancels with all these except for one of them. So we're left with R times, well, P plus Q is 1 over P to the first. R over P. Done. Now, it's tricky. Maybe hard to do without making a mistake. But isn't it beautiful that it works out so nicely? And yeah, I always think it's a good idea to graph these things as a function of P, as a function of the parameter. P varies from 0 to 1. It's going to be a graph that looks like this. The expected value looks like that. What is, maybe I should have made it higher. R is, 1 or 2 or 3 or 4. It's the number of successes. If we're thinking about this with my basketball example, say P is 0.4, and I'm after 10 successes, R is 10, then for me, R over P was 10 over 0.4 is 25, and the output would be 25 when R is 10. If R is something different, then it would be something different. That's a 25 there. For any given situation, P will be fixed. But I kind of like thinking about the fact that if I became a better free throw shooter, then my expected number of trials would go down, decrease. If I increase my free throw shooting percentage from 40% to 60%, my expected number of trials until I get 10 successes would go from 25 down to 10 over 0.6 would be what? 10 times 5/3, like 16 or 17 or so, instead of 25. 16 and 2/3 technically.